I just go back to a quick introduction of what is a script. A script is a sequence of instructions or commands to be executed inside an application at runtime. Let's think of a script as a user program to be run in embedded form within an application. Scripts add custom functionality to an application at a high level without modifying or recompiling the application. They are usually written in high-level programming languages that are easy to learn and allow for quick creation and modification. There are many types of application scripts in use. An operating system command line shell can run scripts, a bat file, shell file, or a per file, even a PowerShell file. All those are scripts. Office applications can also run internal scripts. Visual Basic for applications, OpenOffice Basic are good examples. Web browsers can run scripts embedded in web pages. JavaScript is the main player here. You couldn't think of a modern web page without JavaScript. And last but not least, database engines can run scripts. So database scripts is a sequence of standard SQL commands optionally mixed with script-only available commands for execution, control, and logging. This allows the developer or end user to perform intensive data processing tasks that require several SQL commands to do the job. Many relational database management systems allow to execute many SQL commands at once in what they call a batch mode, but this has its limitations. A script can be split in more than one transaction, whereas batch SQL commands must be performed in one transaction only. A script can provide additional commands for control and logging. A script can be divided in subscripts. The script execution is fully controlled by the client. It's a client-side process. But batch execution is controlled at the server level. A script output can be sent to a log file. And since the execution of a script is controlled by the client, it can provide execution progress feedback to the end user. There are utilities to execute database scripts. This is nothing new. Virtually all popular database engines include or provide tools to run database scripts. In this table, you can see the databases, the popular databases, and the name of the utility that they use to provide the end users to run SQL scripts. These utilities are standalone executables, which require custom installation that makes it difficult and cumbersome to call them or to try to integrate them into your own applications. Also, there is no standard for the script control commands. Each database engine implements its own custom control and logging command. And what if you need to connect or integrate more than one type of database engine? Enter FireDAC database scripting. FireDAC includes a database scripting component, FDScript, which has many advantages over standard database engine scripting utilities. First and foremost, it is a component. So it can be seamlessly integrated into your own application with no hassle and no dependency on any external executable or library, other than the client itself, of course. The object-oriented architecture allows you to extend the built-in set of control and logging commands by implementing and registering at the center of the FDScript command class. By design, the FDScript component is aware of and understands many of the industry standard SQL script syntaxes, including Oracle SQL Plus, the de facto standard, Microsoft OSQL or SQL command, MySQL Monitor, and Firebird or Interbase ISQL. FireDAC built-in scripting commands. This is a quick list of the commands that you have available out of the box with FireDAC. The first ones are to start the execution of a script. You can see that there's several ways to do it. That's because FireDAC tries to implement the specific version that each database engine uses. So the first two is like Oracle syntax, the second one is SQL Server syntax, and the third one is Firebird. So won't go into detail. This is well documented in the FireDAC documentation, but this is just to show you the vast variety of commands available out of the box with FireDAC. Also, it is good to mention that the host or shell command, again, that's because it tries to implement the variations by each database engine, allows you to execute an external shell command, be it an executable or batch command. That comes handy when you do need that, but also it's dangerous in some situations. The set command is maybe the most elaborated one because it has, by design, it has a mix of all possible parameters and configurations combined from all database engines and vendors. So if Oracle's had one set of parameters, it has them. If SQL Server implemented another set, it has them all. So it's a good combination of the best of each one in one single component. This is just a continuation of the options you have with the set command. Script sample. I will show you a script sample that does a complete database initialization within an application. So let's start our CBuilder compiler. The idea of having a database script in an application is that you don't have to go through the burden of maintaining and setting up databases and data with external utilities, or even worse, have someone do it manually at the end user application. So this is our test application for a complete database initialization in an application. By choice of the end user, since we have FireDAC, we are proud to tell our end users that we can support any database they choose. So these specific end users chose Oracle as its own database, but the data of our application that it's been stored in our own company, it's being held in an Interbase company. This is the FireDAC Explorer. This is a tool that comes with FireDAC. It allows you to create connection definitions, which are listed on this side. And once you have created a connection definition, then you can browse the whole schema of the database and the tables. This is our corporate server that has the data we want to export, so this can be loaded on the end user application. This is just a sample, a good old sample of the employee database for Interbase. And this application that we are developing requires the first three of them. Hold on, I need to restart it again. So, start. Okay, our server is running. We can connect. This sample application that I'm showing to you needs these first 6 tables: country, customer, department, employee, and sales. There's one called sales down there. Well, with the FireDAC Explorer, once you have the connection definition, you expand it, it connects, and then you can browse all database objects. As you can see, you can click on the tables and see the contents of that table. Okay, so what do I want to do? I need the data out of my corporate database, which is these 6 tables. I need to export it in a portable format that I can use to upload in the end user application. So I will use the script runner. The script runner is a GUI utility to run FireDAC scripts. Actually, FireDAC in your RAD Studio installation comes a sample of the script runner. This has been enhanced a little bit with additional features and some corners rounded up. I call it the FireDAC Plus script runner. And I have a set of scripts that I will be using to show you how to create the script for the final application. First, as you can see here, I need a script to extract the data of the corporate database. This script will connect to this connection definition, which is exactly the same one I show you in the Explorer. So this is the connection definition name, and it's the same one I see here. And your best friend with the script runner is F7. In the script runner, you can run the full script, which is what you do once you know it's fully tested and debugged. Or when you are developing it or creating it, you use F7, which is step run, just one line at a time. So when you're creating scripts, your best friend is the F7 key. I'll hit F7 and it connected. Hit F7 again. Now I'm doing exporting the data out of the country table to a portable file, which is actually a text file. Let me show you how it looked like. It's being exported to this install directory, and this is how it looks like. It's just a raw, comma-separated value, including embedded field names. So let's go on and do the export of all tables here. The script runner will always show you whether it succeeded or not executing the command, and then at the bottom you'll see okay if everything is fine. If not, you'll see an error, and if possible, it'll try to get the error message out of the SQL server, the database server, and show it here. So what you see with these commands to export the data is that all of them succeeded exporting the data, and it's telling you a summary of how many rows that were extracted. Okay, now we have the data that we need for the initial upload in our end user application. Let's go on with the next script. The next script in our series is the one that creates the user. Of course, when the application is being installed from scratch in an end user workstation, there's no user for our application. Normally, this task needs to be done by a human being, going to the server and with an administrator password setting up the user. But this little script here does it all with SQL commands. Only thing you need is the master password. In case of Oracle, it's called system. That's the master user. And in this sample, I'm putting the password as master. So let's go and connect. We are connecting to the Oracle server. It connected. You see the output here, and connected with the system user in this Oracle database. We continue F7. Oh, hold on, I need to redo one thing here. I'll explain to you what I'm doing in a moment. Okay. I had a user already created, that's why. So I needed to replicate having no user to begin with. So we start again. And this is creating the user and then defining the roles and the rights that this user needs. All these are SQL commands to create a user in an Oracle database with a specific username and a specific password and with the necessary rights to be able to create data. So once this mini script is being done, you must recall that this specific script requires the system user of Oracle with its own password. So this one, you cannot hard code because we don't know the system password at runtime. So, but I'll show you how to fix that with the help of FireDAC. So that's the first portion of our script. The second one is to create the actual database objects, tables and indexes. So again, we go with F7, we connect to the Oracle server, then we start running one by one each one of the SQL commands. So we created table country, table customer, department, we are creating employee, salary history, sales, phone list, and then the indexes for all those tables. All these commands are creating the indexes. Okay, so once we reach the end, how do we know it was created? Well, very simple. Let's use the FireDAC Explorer. Now I can connect to my application user and see that effectively my app user, here you can see the 6 tables that were just created. But as you can confirm, they are empty. They were recently created. They are empty still. But we are okay. That portion of the script is working fine. We already succeeded creating a user. Now we succeeded creating tables and indexes. Now let's go to the next step. Next step is to load the data. Now this is critical. One might think that why shouldn't we create tables, indexes, and constraints and foreign keys all at once? If the purpose of your application is to start with a completely empty database, that's okay. But if you're going to do some initial data upload, such as the one I'm showing to you right now, then you can't do that. Constraints, specifically foreign keys, always make noise if you try to add data at once. So the trick that I'm showing to you here is that you must always first create tables and indexes only, with no constraints, no foreign keys, and then next is to upload the data. So that's what we're going to do at this step. We are connecting, and then the command that we are using is the reverse version. We are grabbing data from the portable text data files and inserting them into the tables we created in Oracle. So we execute them one by one, and you see at the bottom that they are succeeding one by one. So this piece of the script is working again. How do we know that it worked fine? We use the Explorer again. Now you see data. You can see this is the data that was uploaded. All tables now have initial data. They were empty a few seconds ago. So let's go to the next script, which is to add the constraints. So let's add all constraints here. Again, F7 is your best friend. We connect, and then we start applying one by one each one of these constraints and foreign keys. The idea of running it one at a time is that you can confirm yourself that all the commands you typed in or copy-pasted or whatever are succeeding individually before you allow the script to run on its own as a whole. And the good thing is, since this is being interactive, if it fails, you just fix the command right there on the editor and bring the cursor on top of it and run it again with F7. So the interpretive nature of the scripting helps a lot to debug and create and develop the scripts very quickly. No need to compile anything. Okay, we are done creating all the referential constraints. And now it's time to tell you how to fix the issue for the Oracle password that we didn't know. Well, let me introduce you one feature of FireDAC that is very well supported. This is the version of the first script that creates my application user in Oracle only that instead of hard-coding the password, such as the username, same as the username, now I'm creating a macro. This macro is Oracle style, but is fully supported in FireDAC. And the best thing is that it works with any database because it's under FireDAC's control, not the server. So we are defining a macro called system password and defining the value of the macro to be master. That's exactly the value that I had hard-coded here. So let's see if it works. I'm going to go back again to the top. F7 is our friend, but now we need to go to the macro definition so it gets executed. F7. Now, how do I know that the macro was defined? If you execute the define command alone with no parameters, then FireDAC will print all the macros that are currently defined. So you can see we have define system password and master. So we know that the macro was defined. We continue executing the connect command. It succeeded. So you see that it's connected. That means that the macro substitution worked fine with no problem. So we know that this will work with the macro substitution. So now we can assemble all pieces together and we can come up with a global script that will do it all. So I added all those mini scripts that we developed individually, separately. And we have first the definition of the macro, then the connection with the macro substitution. First, we are connecting as a system user in Oracle. And once the application user has been created, then we connect again, but now using the application user. Once we have the application user set up, then we can define creating the tables and indexes. Later, we upload the data. And at the end, we apply all constraints and foreign keys. To test this whole script, I need to drop my application user because it's already created. If I run this right now, it'll give an error because it will say that the user already exists. So before we run this one, let me run this tiny script that the only thing it does is drop the user. Okay, user has been dropped. How do I know that? If I try to connect using the user, no, it didn't allow me because I was using it. If the user is connected, you can't drop it. Actually, here's the error. You can't drop a user that is currently connected. So I'm going to exit Explorer so it disconnects fully, and then I'm going to try again. Now it succeeded. You can see, okay, I deleted it. If we connect again with FireDAC Explorer, it will give me an error. Invalid username password. The user does not exist. Okay. Then we can test our global script that does it all in one big script. So we go to the top. Let me clean the log. So I'm putting a clean log for you. And now we run the whole script. You want to know how much it took? In 3 seconds, almost 3 seconds, it created our application user, it created all the tables, it did initial data upload, and then finally it applied the referential constraints and foreign keys. How do we know it works? I go back here, I try to connect, and now it succeeded. No more errors. And I go look for my tables, and see they are there, and they have data. A few seconds ago, there was nothing. Now we have the user, and we have the tables, and we have the data. Fine. Now, let's plug this into our application. But before I do that, we need to drop the user again so we can test it inside our application. Okay. So the user has been dropped. I go back to our own application. Here we have the script component. This is the FireDAC script component. You define the script by opening this collection and adding the script here. This script is identical to the one we just developed externally, with the only difference that I don't have the macro definition at the top. I don't want the macro hard-coded. I want the macro to be driven by user input in my program. So the only place you see the macro here is for the actual substitution. It means to substitute the macro with the right value once it runs. But I'm not defining the value of the macro here. We will do it dynamically at program execution. So how do we do that? We go back to the script component, we go to macros, we click on the button to add a new macro, and we define the name of the macro to be exactly the same as the one we have in our script, which is system password. And then you must define the data type of the macro. I will recommend you that you almost always leave the default data type, which is raw. Raw just means that the substitution will be done as is, as you defined it. So, because the other data types that FireDAC have try to do some formatting, specifically for dates and some numbers. But in reality, most of the time, you just wanted the macro to be substituted exactly as you defined it. So that would be like the default way to go to me, unless there's a specific case and you are aware of it. So we have the macro named system password, data type raw, and the value master. That's for setting up the macro. So now the macro is known in the collection of our script component. Next step is to add some code to get the value from the user. So here we are asking the end user to input the password of the Oracle system user. We store it in a local variable, and then we assign it to the script through the macro collection and the macro method. We assign the value, then we run the macro. Finally, we are running the whole script. Let's see how this runs. Here we have our application. We click on Initialize Data. It's asking us for the password of the Oracle system user. We define it, hit Enter. Script is running. That's some of the issues when you have too much software components running at the same time in one single computer. Anyhow, another workaround. I'm restarting the Oracle service. Got it. Now I need to delete the user again so I can show it to you. Okay. Okay, it was never created, so we can go here. There we go, we have our application again. We run it. We click Initialize Data. Type the password for the system user. Script is running in the background. Application data has been initialized. How do we know that this ran fine? Well, we just click on Open Data. And that's it. And this is just a quick sample of the magic you get with FireDAC and scripting and database scripting. All database initialization, including the brand new database user, was done with one single script. Compare that to doing manual setup and manual copy of the data, doing backups, etc., etc. Close this one. Then also to show you, I have how to add custom scripting commands in FireDAC. To create a new FireDAC script command, you must define a new command class inherited from the fdscript command, and then implement the following mandatory methods. These are the bare minimum methods that you must define in order to be recognized, which is the help method, the keyword for the command itself, parse, which is the method that analyzes and parses the command, and execute, the one that finally executes it. Once your new custom command has been fully implemented, you must register it at runtime with the script command registry of FireDAC. So the standard way to register a FireDAC command is calling the singleton class called fdscript command registry. This one allows you to add and register script commands. However, it lacks a replace function to alter the behavior of built-in commands, and also lacks the ability to delete or disable a specific built-in script command. For example, the host or shell command in script is powerful, it's beautiful. But what if in a specific application you don't want your end users to run any external shell command? That will be like a security hole. So you may want to disable that specific command out of all the rest available. So that is one key problem I have found with a script command registry that comes standard. Companion to this presentation, I have a little library called FireDAC Plus, and implemented a script command registry, FD Plus script command registry, singleton class, that can also add and register a script command, but can also replace and delete and register any script command. So as a sample, in the initialization part of your code, here we are adding these 4 custom commands, and then we are deleting the shell command. Here, basically you are doing is removing the shell command from the built-in list, because the way FireDAC has been designed is it implements all the commands at once, so you have no choice. You don't have an option to enable just 1 or 2. But with this enhanced script command registry, you can delete a single command at will. This is a sample of 4 custom script commands that I'm including also in the presentation as a small library called FireDAC Plus. And these 4 commands act as follow. One of them is the connect script command. This one accepts connection definition names, as you have seen in the samples that I showed you. Standard connect command in FireDAC, you must provide all parameters for the connection. It's funny, it doesn't recognize definition names, though you can see them all the time in the FireDAC Explorer. So that is one improvement. So the connect command behaves the same and can recognize these connection definitions. Copy script command allows for optional parameters to set to define the separator and delimiter for the text. So if you have something that is not standard comma separated value, like a pipe or tab delimited, then you can, with this extension, define those. The host script command has been vastly improved. The one that comes standard with FireDAC, unfortunately, is not serial, is not sequential. Once you call a host command, the script will continue running on its own. So if for some reason your script depends on the result or output of the shell command, standard FireDAC command won't help you. This one does. This one does wait until the command has been fully executed before it can continue with the next SQL command. Also, as a plus, if the executable you are running is a console text mode command, then the output of it will be put in the spool log window. So it will be part of the spool of the script. And finally, the spool script command adds an extension so you can define a subscript in memory, so you don't have to create a file in disk for quick and dirty SQL subscript. Are we on time to show this last one? I'll just keep ahead.
Yeah, it's okay. Go ahead. We've got another 10 minutes.
Okay. Then I'll show you a more elaborated sample of scripting, but this is using several databases at once. So I'll call this order. We'll use our friend, the script runner plus. And now I'm gonna call this, I'm loading up this script, which is a fairly long script. I won't show you how it is created because it can be very time consuming. With a very simple one, it consumed a lot of time. But I wanted you to see how easy it was to create a script that does it all. This one goes a step further, and it's trying to combine data from several database engines from different vendors. So I'll just quickly go through it here and then show you how it runs at the program level. So it gets exchange rates from an accounting system that is in SQL Server, and thus extracts the data to a portable data format, the text portable format of FireDAC. Then it connects to a production system that I intentionally put it in DBase, because this is one of the tricks that I will show in the other presentation in 2 days is for migrating from the BDE. This is one of the tricks. FireDAC can connect to DBase. It's not native, but FireDAC can connect to ODBC databases. So all Windows machines starting Windows 2000, from Windows NT 2000, come with what they call the Microsoft Database Driver, ODBC driver. So you can leverage that, take advantage of that. And then FireDAC, you define an ODBC connection in FireDAC with the Microsoft Database driver. You just need to set the parameters correctly. This is very well documented on the Microsoft side. You can even use the ODBC configuration utility that comes with the ODBC administrator. I'll give you one trick that you might already know. You must know this trick. If not, I'm going to tell you anyhow. Is that once you launch the ODBC administrator, if you define a system DSN, the entries are created in the registry of Windows. Then you need to use the registry editor or something else to get the actual parameters that you configured here. But if you define a file DSN rather than a system DSN, then instead of storing them in the registry of Windows, it creates a file. And the beauty of this file is it is text-based. So within these files, you can get the actual parameters that you are configuring with the GUI tool. So whatever you change here, once you save the DSN, it will be stored in a text file, a raw text file. I'll show you the contents of this one. because then it's always hard to remember all the settings and parameters. So where is it? Okay, here. ODBC, where did I put it? I don't have them here. Okay, I don't have them here. So then you can extract from those DSNs, hold on, production data, production control system, ODBC DSNs, I put them here. So this is how it gets created by the ODBC administrator. And here, driver, put it apart, and the rest, you just concatenate them with a semicolon, and then you get the parameter needed for FireDAC. Actually, that's exactly what I did in the other file. The other file here is just a concatenation of all those parameters other than the driver. Then this is your connection screen for FireDAC. You go back to the FireDAC Explorer, define an ODBC connection, you name it the one you want it, and then ODBC, first you define the driver. In this case, we're talking about the Microsoft device driver, and then on ODBC Advanced, you plug the whole string you just created, concatenating the parameters. We confirm that it works by opening it up, and you see that there's two tables. I define a DSN entry for this directory that has these two DBase files. So these two are completely available and shown here. So that's how I'm defining a DBase database system in FireDAC, which seems odd or not natural, but you can. So this portion is extracting data out of that DBase production system. Then it connects to an interface system to get some employee data. Then it goes to Microsoft Access to get parts files, parts data. And at the end, it uses the local SQL feature of FireDAC using the SQLite to do some data crunching. So once it gathers the data from all these several sources, they are all now imported into local tables in the SQLite work data database. This one that is defined here. You must recall that this must be set up by your FireDAC Explorer. You must have your FireDAC Explorer defining all, because I'm using connection definitions. So since I'm using connection definitions, that means they were previously created. Here is my SQL work data. And the location of the data file is here. All right. So it does some data crunching, processing, which we standardly call ETL, extract, transform, and load. So all this is done with the local engine of SQLite. And at the very end, everything is uploaded to a data warehouse in an Oracle database. So at the very end, we do some upload into a staging table that has the daily processing, and then we append that daily data we just crunched into a historic table. All this is just showing you how you can mix all kinds of multiple database engines in one single script. And using the export-import feature of the portable data by FireDAC, these text files, you can just switch back and forth and move the data around. And also one good feature is having the SQLite engine, then all the crunching is done locally at the workstation the program is running at. That's an option. Maybe you want it to run at a full-blown SQL server for power or for speed, but that's your choice. That's the good thing. With FireDAC, it's up to you. You are not constrained to a single database system. You can use any. You are mixing them at your will. So let's go to the application to have that one run. I call this sample application my ETL processor, my extract, transform, and load processor. What it does is I have one thing that I didn't tell you in the previous application. If you think your program will be calling a lot of database engines, then you must link all the drivers for all possible engines that you might be calling. Otherwise, you will get a runtime error. Let's say that in my script I'm calling the Oracle database, but I didn't drop the Oracle driver here. Then everything will compile and everything will run. But at the very moment that the script tries to connect to the Oracle server, it'll yield a runtime error saying driver not found. That's because I forgot to drop this component here. So specifically, when you have this type of multiple databases in an application, you must drop all drivers that you think will be needed, regardless they are in the script right now or not. Anything that you think will be needed must be added to your program. Also, I'm adding what FireDAC calls the script running dialog. I'll show you what it is. The button to run it is pretty simple. Oh, sorry, I have the component for script here. So in this component, the script has been added. It's the exact same script you just saw externally, the one that I was running on the script runner. It's the exact same script. To make it simple, this one doesn't call for parameters. But if you needed some kind of parameters, you can use the same idea we did in the previous sample program of defining macros that you can pass over by using the macros collection here, in case you needed some real external input to your script. Okay, so once this has been set up, the only thing you need to do when they click the button is to just execute the script. That's all. So let's do it. So we call it to run, and this is the script runner dialog. This one shows up only if you drop the component there. If you drop the component on the application. If you don't see this progress, like in the previous application. Hold on, one of the servers is down. I will remove that one just to make it easy. Hold on. I'll just show you how it runs. Okay. All right, so let's run it again. As I was telling you, if you don't drop this component in your application, then the scripts run blindly, as they did in the previous program. In the script runner, it is showing you the progress until it gets completed. How do we know that it ran fine? Well, we open the data. This was the data that was crunched for today. And once it uploaded it into the data warehouse in Oracle, it appended it to the historic data. So what was processed just today has been added to the end of the historic data. So this is a good example of an extract, transform, and load program among multiple databases. Just quick thing before we go is when deploying your database scripts in your finished applications, if you end up using this enhanced version of the command that I showed you, the one that can use connection definitions, there's one trick, there's one catch. The connection definitions are exposed by the Explorer via this FD connection dev-cine. Of course, you don't want to be exporting this into your application. So the way to replicate the connection definitions in your program once you deploy it is to add them in code. So rather than relying on this global configuration file that is maintained by the Explorer, instead of that, you add them in your own code. You do it by adding these simple commands. Something like this. You define, with the help of a strings variable, you append the parameters, and then once you have the parameters in the string list, you call the FD manager. This component is always available. This is the main manager engine of FireDAC. So just by adding any FireDAC unit or component to your program, this is available immediately. So you just call from FD manager and the method called add connection definition. You name the connection definition exactly the way you would do in the Explorer. So if you have the one Oracle, MyDB, My App, then here you define exactly that name. You must say what type of database it is, the same way you do in the Explorer here. It must be one of these IDs. Oracle, MS SQL, MySQL, whatever. So it must be exactly one of these database types, and then the variable that is holding the parameters for the connection. And that's it. Once you do this, then the FD manager exposes these connection definitions to the script component. And then you don't need to distribute any configuration file. Everything is completely embedded in your program. Additional resources and documentation. FireDAC documentation contains fairly good amount of detail about the FireDAC database scripting capability. But some must-have additional features have been provided in this presentation via help of the FireDAC Plus companion library. You can download the full sample source code of this presentation, plus the presentation, the script GUI runner, also the script console plus runner, and the FireDAC Plus library from my site, delfiguru.net. You'll have to wait until tomorrow because today I had issues with the presentation, so I'm not sure they are completed. For sure, tomorrow they will be complete. Thank you so much.
Okay, thank you, Miguel. And there was one question. I handled the other ones. Can all of this be done with image and text blobs?
You talk about any kind of blob, right?
Yeah, it can all this work with blob types as well?
Guess what? And I know why they are asking, but that's something I got from FireDAC. It does work with blobs.
Excellent.
But one must be careful because since the portable format for exporting and importing back is text, so it works, but the text files can be very big if the blobs you are working with are big also. So if you just keep that in mind, yes, definitely they work. And this is in comparison with other utilities. For example, the good old DBase and FoxPro commands to export data out, they never worked with memo fields or blob fields. They never worked. So I know what they're asking, but FireDAC is fully supported. Any data type recognizable by FireDAC is exported in this portable text version. Actually, the blobs are an hexadecimal string, character string, so they are kept intact. They are not even converted to characters. They are a hexadecimal representation of the blob field.